Okay, welcome everyone. This is the week 4 webinar for the elementary stats course. And the plan today is we will, as always, I'll take any questions you might have if you have any questions. And then after that,
Get out of here, butthole.
I don't think I said anything bad. The standard normal distribution is what we're going to be talking about, and the normal distribution. We've talked about what distribution have we already talked about in this class? We've actually had 2 other distributions besides normal. Yeah, uniform. What was the other one? Uniform was one, and the other one was? Bimodal is a shape of a distribution. It's kind of similar to sounding, at least. It's binomial. And the interesting thing is I was just watching actually a Harvard lecture on probability. I think it was an upper division class. I do it for fun while I work out. And he was talking about the uniform distribution, and it's actually the starting distribution to come up with any other distribution. So the uniform distribution is really important in kind of the deep part of things on computers to get things. The uniform distribution is the way you get it. But the normal distribution, it turns out, is absolutely the most important distribution in statistics. So we have an entire chapter just on the normal distribution. And this is chapter 6 and chapter 7. It's pretty much another chapter on the normal distribution. But it has something called the central limit theorem, which is why we use the normal distribution. Today, we're not going to necessarily see the whys so well. But we'll start out with the standard normal distribution. We'll talk about calculating probabilities and percentiles from the normal distribution. We'll look at the general normal distribution. And again, if you don't understand what this stuff means now, it's fine. If you don't in an hour, then it's not fine. Okay. And then we'll also calculate probabilities and percentiles of the general normal distribution. We'll also look at a couple applications, not the main applications, but at least some stuff we can do now. We're going to assume you have a normal distribution, which turns out later on we're not going to have to assume that, but this week we're going to have to. That's how it works. So as I mentioned, the normal distribution is really important. I'll also give you a heads up. This is week 4. What's important about the number 4? Yeah, the 4 is an even number, and we have an exams on every even numbered week. And so don't forget there is the week 4 exam to take, and that's important. So week 4 exam covers everything we've done so far, but it has a higher focus on chapters 4, 5, and 6. So it's a higher focus on 4, 5, and 6. In fact, the open-ended questions will be chapters 4, 5, and 6. I won't tell you which ones, but they could come from any of those. So it's just a note, there is a week 4 exam. Even though it's due on Sunday, I don't recommend doing it on Sunday, because if things go wrong, if your internet dies on Sunday or something, and it's your mistake because you didn't do it like on Friday. So the idea is try and get everything done by Friday, and then if you need more time, ask on Friday, and I'll give you extra time. But if you ask on Sunday, I don't give extra time. That's been the rule from the beginning. So very important to note that. Kind of think about everything due on Friday, and you always get a 2-day extension if you need it to Sunday. Sound good? Kind of the way you want to look at it. Okay, any questions about anything? And that could be the projects at this point. I know some of you let me know already you're getting involved and you've collected your data, which is where you should be at this point. So hopefully you've all gotten the data collected, because that's really important. And then I would say this week, have your data collected and start writing. And then post on the Project One forum if you have questions about it. So that's my recommendation, is to get it moving. Get it moving. You have all the information you need for it. And some of what we're doing today will be something we've already talked about, but we're going to reinforce it, which is part of your project also. And that's part of the normal distribution. Okay, any questions at all? Again, feel free to ask questions. That's always like one of the main purposes of this whole of why we're doing a webinar, live. Any questions? You're going to use this information on the project. So what you're going to need on the project is a piece of information we've already had, but now we're going to have it in like more depth. So in a way, you've learned everything already before today for the project, but the empirical rule is more depth today. Because remember, the empirical rule was about if you have an approximately normal distribution, how do you find probabilities? Or how do you work with probabilities? And that is something we'll do more of today, so you'll get reinforcement. Does that make sense? So that's the only piece that you have to know. And I guess reinforcement on the shape of a distribution that's normal. Okay, any other questions? If you don't have anywhere near a normal distribution, you cannot use the empirical rule. So if it's nowhere near a normal distribution, you can't use an empirical rule, but there is a plan B if you can't use the empirical rule. Empirical rule is best, but what's a plan B if you can't use it? Remember? And it's another one, but it's hard to spell. That's a hint. Yeah, Chebyshev or something. As I said, it's hard to spell. Let you look, when you're writing the project, I'll let you look up the spelling of it. Yeah, so plan B is Chebyshev's. Chebyshev's is not as powerful as the empirical rule. So if you can use the empirical rule, there's no need to use Chebyshev's. You should use the empirical rule, but if you can't, then you should use Chebyshev's. Does that make sense? Okay. All right. So as I mentioned, I'm always happy to answer questions throughout the entire webinar. So feel free to post more or ask, vocally, either way, and I'll be happy to answer questions as we go on. It could be about what we're talking about, or it could be about anything else. Okay. And one more thing, today will probably be a shorter webinar than usual. Chapter 6 is usually not one of the harder chapters, but it is a very important chapter. So it's an important chapter because the normal distribution is the most important distribution in all of statistics. And there isn't anything even close to how important normal is. We are going to be looking at other distributions, and it turns out all the rest of the ones we look at are somehow coming from the normal distribution, like refinements of it. Okay, so I have a picture, and this picture is really important. And what does this picture show? What's the name for this picture? It shows a normal distribution, but then there's these special numbers, and one of those numbers is a name for the numbers, or a name for what this is. So there's normal distribution, and there's more to it. Remember? Centiles, no. It's the empirical rule. Do you remember that happening once? Yeah, the empirical rule. So notice that 68% of the data fall within one standard deviation of the mean. 95% fall within 2 standard deviations, and 99.7% fall within 3 standard deviations. Okay, now it turns out when you have a normal distribution, there are 2 numbers that are important to understand what kind of normal distribution you have. And they're the 2 most important statistics there are. What are the 2 most important statistics of all statistics? Not a trick question. We've talked about it in a big way already, lots of times. That's how important it is. Z-score and standard deviation is one of them. Z-score is important, but there's something more important than Z-score. Probably more important than standard deviation. Yeah, the mean. So the mean and the standard deviation are the most important statistics. So just to let you know, we call it a standard normal distribution. What is the mean of this distribution, the way it's written with these numbers? You should be able to look at it and just see it. What is the mean? I'm looking for a number. Yeah, 0. The mean is 0. You see? It's right in the center, and that center point is 0. Any guess on what the standard deviation is of this particular distribution? That you should be able to see too. Yeah, that's 1. So we call it the standard normal distribution. If it's a normal distribution with mean 0 and standard deviation 1. And that's like the easiest one. That's what we call it standard. It's its own z-score, for example, because if you subtract 0 and divide by 1, you get where you started. So it's just easy. And the 0 is a center. The 1 geometrically is a little harder to explain. Any of you had calculus before? My guess is no. Without calculus, it's hard to understand what's going on in terms of the picture. But there's some calculus stuff which I can't talk about because that's not a prereq. Yeah, it may not. I'm not even sure if it's in business calc so much. I'm not going to get into it, but it's something called an inflection point. Okay. And by the way, something I want to mention, the normal distribution has, if you look at this is much, 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 much harder than the uniform distribution to find area. Okay, if you want to find area under a curve that's general, right? Between -1 and 1, it's 68% about. For other numbers, to come up with that, even the equation, this is a curve, right? The normal distribution is a curve. It has a math equation, right? Any guess on what the math equation is? And I'm joking, you're never going to guess it. It's 1 over sigma times the square root of 2 pi times e to the negative x minus mu quantity squared all over 2 x minus mu over sigma quantity squared all over 2. Negative that. It's a brutal formula. And the good news is you do not have to know that formula for this class. Got it? I said it fast. I'm not writing it down. But just know there is an equation. That you should know. Somewhere along there, there's an equation. And even if you had calculus, just let you know, finding area is, even if you've had calculus, is brutal. Something you haven't even learned how to do with that. That equation is one of those evil ones. So I'm not going there. Instead, I want you to know the empirical rule and at least get some of these things with the empirical rule. So I'm going to do some examples. So suppose that Z follows a standard normal distribution. Make that a little bigger so you can see it better. Use the empirical rule. So part A, we're going to have a few of these to do. Find the probability that Z is between -1 and 1. So the first thing I want to let you know the symbols. We did this with the uniform distribution or something similar. Do you remember that little symbol right there? Remember what you call that? We've used that one last week. Yeah, that was a tilde. And what it means is has the distribution. So Z is the variable that has the distribution. This should be obvious. What do you think N stands for? That should be obvious. Yeah, N stands for normal. 0 is the mean. 1 is the standard deviation for this example. So if we're in that case, find the probability that Z is between -1 and 1. And the hint is it's really easy. You don't need any calculator or anything. How do we find the probability? Z is between -1 and 1. Yeah, all you do is look at the picture and you say between -1 and 1 is 68%. Turn that into a decimal, and you get 0.68. Do you agree that was really easy? All you have to do is look. Any questions so far? Okay. The next one, find the probability that z is less than 3. That's harder. Is there a significance to z? So we'll get there. We'll get there, I promise. So why are we using the letter z instead of x? There's a reason. And there's going to be a question and you'll see it, but we're not there yet. Okay, find the probability that z is less than 3. So I promise you I'll answer your question, but a little later. So how do we find the probability that z is less than 3 without, using any fancy calculator or anything? So from the picture, there is one thing we know about 3. So if you think about 99.7%, that's not the probability that z is less than 3. That's the probability that you're between -3 and 3. Do you see that? So what happens is that 0.997 is not the probability that you're less than 3. We also have to add this extra piece in. So what we're going to do is we're going to write that as a probability that -3 is less than z is less than 3. And then we're going to plus the probability that z is less than -3. And the idea is, if you look at the picture, if I take all the stuff less than -3 and add it to all the stuff between 3 and -3, I get all the stuff that's less than 3. Is that clear? Okay, I see in the chat box, you got some good ideas at this point. So now we put it all together. So that's equal to the probability, oh, sorry, that should be a 3, not a 2. Typo. That's the probability that z is between -3 and 3, is 0.997. And then we need to add the probability that we are to the left of -3. And again, we can use the rule of complements to say to the left and to the right combined will be 1 minus 0.997. But we only want the left. And one great thing about the normal distribution is it's symmetrical. So the left will be half the combination of the left and the right. So we can do plus a half times 1 minus 0.997. Any questions on that? And that, again, we can do it in our head if you want, calculator, whatever, 0.997. And then plus 1/2 times 1 minus 0.997 is 0.003. You put parentheses. And that is equal to 0.997 plus a half of 0.003 is 0.0015. And then I can say 0.997 plus 0.0015 is 0.9983. Sorry, 9985. That's better. Any questions? Any questions about part B? Okay, I didn't do anything too fancy. What I did is I just broke it up into 2 pieces. The first piece is really easy. The second piece, I can say, well, if I take left and right, put those together, that's going to be the complement of the first piece. So I'm going to take half of the left and right and put that together and then do basic arithmetic. Have I lost anyone on that idea? Okay, next is find the probability that z is between -1 and 2. So now I want it between -1 to 2. Okay, and we're going to do something similar to that. So how can I break it up first? I'm going to break that one up between -1 and 2. I can break that one up into two pieces. What pieces should I break that up into? I don't see you all jumping in. Okay, I can say, well, -1 to 2. I can go -1 to 1, and then add 1 to 2. Do you see how those two pieces together give you -1 to 2? That's the probability that -1 is less than z is less than 1. In other words, you want to break it up into at least one of the pieces that we can easily get, plus the probability that 1 is less than z is less than 2. Yeah, so -1 to 1, that, from the empirical rule, is 68% or 0.68. And then we're going to add, now we want the probability between 1 and 2. So the idea is we know between -2 and 2, we know between -1 and 1, and if I take between -2 and 2 and subtract between -1 and 1, I'm going to get these two pieces, -2 to -1 and 1 to 2. By symmetry, those pieces have the same size. So if I divide the two pieces by 2, then I'll get between 1 and 2. So that's going to be 1/2. And then times, now I want to go between -2 and 2, which is 0.95, minus 0.68. Any questions on that? Any questions? Okay, and the rest is basic arithmetic. I think I'm going to save you time. You know how to do arithmetic. You can stick it in the calculator if you want, regular calculator, just basic calculator. Or maybe I'll even do the fun arithmetic. Copy, paste, and Google tells me, they tell you gotta hit equal. I may not like this half as it is. Now I like it. 0.815. Simple arithmetic. Any questions on that example? Okay, let's do the next one. Find the value of z such that there is a 2.5% probability of being greater than this value. So the first thing that I think helps a lot, if there's a 2.5% probability of being greater than the value, is this value far left or far right? I like to think of it if 2.5% of the people are taller than you, are you tall or short? And you're tall, so it'll be on the right. Okay, so it's going to be somewhere over here. So it's going to be a positive number. Is that clear? So it's going to be somewhere far right. And the idea here is that we know the area to the right of that will be 2.5%. So now what we're going to do is we're going to say, if you add the left and the right, so you're going to have this piece to the right is 2.5%, and then you're going to take the mirror reflection and say to the left of that is 2.5%. So how much is going to be on that kind of far left and far right sides on the 2.5% on each side in combination? What percent? Yeah, 5% will be, let's do it this way. Got small. 5%, still small. Making it big. There we go. Okay, so 5% will be on the far left and far right in combination. How much will be in the middle if there's a 5% on the outside? How much is in the inside? Yeah, therefore 95% is in the inside. But now we're in great shape because 95% is between -2 and 2. So is our answer -2 or is it 2? It's 2 because we know we're on the high side, not the low side. So the value of z is 2. Was that easy? A little bit of basic arithmetic and understand the picture. Any questions so far? Okay, let's see if you can find the 16th percentile. So now, if you're in the 16th percentile, imagine like in height or something. Are you tall or are you short? Yeah, if you're the 16th percentile, you're not tall. 16th percentile means 16% are shorter than you, and everyone else is taller than you. That's what percentile means. Is that clear? So that means 16% is taller than you, 84%, I mean shorter than you, and 84% are taller than you. You're a pretty short person. Does that make sense? You're not tiny, but you're definitely not one of the, you're one of the kind of on the shorter side. Okay, so that means since we know we're going to be on the short side or on the left side, that means we're going to have a negative value. So note that z will be negative. That's the first thing. Then we can say that since 16% is on the left, 32% is on the left and right, a right tail. In other words, take a mirror image and look at the other tail. How much is in the middle? If 30% is on the left and right tail. Yeah, therefore, 68% is in the middle. And now you smile because you say, aha, 68% is one of our numbers. Is that clear? That it's 68%? Okay, 68% is between -1 and 1. Z must be negative, so what's our answer? -1. Any questions on how that works? Okay, so the last one is so easy, I'm gonna just do it. Is if z is 1.3, let's find the z-score for this value. So if you remember, z is x minus mu over sigma. That was a formula for z-score. Mu is 0, sigma is 1. Hopefully you can all do this in your head. What's 1.3 minus 0? 1.3 minus 0 is 1.3. What's 1.3 divided by 1? 1.3. Notice that we started with 1.3. And if we wanted to find the z-score, we always end with the same number. And there's nothing special about 1.3. I could have asked you, I don't know, negative 2.5. Subtract 0, divide by 1, you get negative 2.5. So you had a question, why are we using the letter z? And the reason is if you're at the standard normal distribution, then the z-score is just whatever you started with, because you're subtracting 0 and dividing by 1. And that's why I like to use the letter z for the variable for the standard normal distribution. That wasn't supposed to be that tricky. It's tricky because the answer is what you started with. You're like, I didn't seem to do anything. Okay. So for example, if we have, let's say the value of negative 3.4, what's the z-score for the standard normal distribution? If we start with the value of negative 3.4, what's its z-score? Negative 3.4. There's nothing easier than that, right? Any questions at all on this idea? Okay, so now we're gonna get harder. Okay, let's suppose that x follows a normal distribution with mean 114 and standard deviation 23. So we basically have a similar shape, but it has a much bigger standard deviation and a mean that's 114. So it's kind of moved and stretched. Okay, find the probability that x is between 100 and 120. And by the way, if x follows a normal distribution with mean 114 and standard deviation 23, we write that, and I'm going to ask you to do this, by the way, possibly even on the exam. So make sure you know how to type this. X tilde n 114 comma 23. Why am I not using the letter z anymore? Why am I not using z? Why'd I use x now? I totally changed it. Yeah, if you found the z-score of some number, you're not going to get what you started with. If you have a normal distribution that's not standard, a mean that's different, and a standard deviation or a standard deviation that's different, then the z-score will give you a different number than what you started with. So we use x. Any questions on that? Okay, so by the way, we have a normal distribution. X is between 100 and 120. And by the way, if you look at 100, and if we use z-scores to see, maybe we could do it that way by using empirical rule. And you find the z-score for 100. 100 minus 114 is negative 14. Negative 14 divided by 23 is that. Do you agree? There's nothing nice about it. Do you agree? Okay, so you cannot use the empirical rule for this question. Is that clear? What you can think about is, well, we want to be between 114 and 23. So we're going to be between, a couple values here and here. That's the area under the curve. When we had a uniform distribution, you just did base times height, right? Do you remember doing that for uniform? Why can't we do that with the normal distribution? What's wrong with just saying, just take the base times the height? Yeah, the height's curved. We don't have a rectangle. Okay, if you don't have a rectangle, you can't just say base times height. That does not work. Okay, so if you wanted to do this mathematically, let me tell you what you would have to do. You would have to take a full year of calculus. Even the first 2 quarters, in our work quarter system is not enough to learn how to do it. It's brutal. So I will let you know if you had to do this using calculus, you may be shedding some tears. So why is that good for us? If I tell you it's really way too hard to do, why is that good news? To answer a question like this. What is the probability that we're between 120, 100 and 120? Not you want to do it. Yeah, it means that you can use a calculator. Just trust the calculator and let it do it for you. So let me show you the calculator. And hopefully you can guess, especially since we do things in order for this calculator, that's how I created it. What calculator do you think we're going to use? Yeah, calculator 8, normal probability. I will let you know, this is a very important calculator. This is the main calculator for this week and the main calculator for next week. So we're going to be using it for a while. So get used to this one. So here's what it says. Since it's such an important one, I'm going to read it. Fill in all the values except one below and hit calculate. Then the last value will be given to you. And it asks for the low, the high, the mean, the standard deviation, and P. Okay, what does P stand for? Any guess? Yeah, probability. Okay, P stands for probability. So you're going to do all except one of them, and then you're going to hit calculate. Okay. And by the way, there's a thing down here at the bottom. That's basically a message box that's going to tell you things. So if I hit calculate without doing anything, it'll give you a message block. Please leave only one of the boxes blank because it can't find everything if there's nothing given. Does that make sense? So it'll give you a message if there's an issue. Does that make sense? All right, so let's take a look at what we've got. We want the probability that X is between 100 and 120. What is the low for this example? Yeah, the low is 100. What is the high? There's no tricks here. What's the high? Not supposed to be hard. Yeah, the high is 120. What's the mean? 114. What's the standard deviation? 23. How about P? Yeah, we don't know. That's the question. So we leave that blank. You need to leave one of them blank, exactly one of them blank. So now I'm going to go to the calculator and we have 100. We have 120. We had, remember, 114 and 23. And we put those in for the low, high, mean, and standard deviation. We have this one left blank. Now I can hit calculate. And what we get is the probability. And by the way, this is way more decimal places than you would ever need in your life. So I just let it, pick as many as the computer can handle. Often, like here, I ran it to 4 decimal places, 0.3315. Okay, and by the way, I don't know what you did over winter break. Any guess on what I might have done during winter break? One of my main things? I skied a little. Unfortunately, I had to hike a little because we don't have much snow. We still don't have much snow. But one of the main things I did is I coded. I did computer programming. And what I coded was the picture. So this is brand new. If you find any bugs or mistakes, please let me know so I can fix them because this is all brand new. If you took my class last quarter, you would not have seen the picture with the calculator. Now you get to see it. And there's going to be pictures throughout the rest of, most of the rest of these calculators are going to have pictures. So, please let me know if you find anything. Good, good. I'm glad you like the visualizations because that's what I put in. So you can kind of see between 100 and 120. The mean was 114, and our probability was 0.3315. So 4 decimal places. Any questions? Any questions on this example? Okay, let's go to the next one. Find the probability that x is greater than 200. So, what is the lowest value that's greater than 200 for this example? And one hint is this is a continuous random variable. 0 is not greater than 200. 0 is definitely less than 200. Yeah, 200 point, a trillion zeros and then a 1 is definitely, one of the lower ones greater than 200. Basically, computers don't even care about a trillion zeros and a 1, so we can just write 200. And it turns out, if you set the low to be there versus, just greater than 200, you get the same answer because with a continuous variable, greater than or equal to mean exactly the same things for a continuous variable. What's the highest number greater than 200? And that's a trick question. That's a hint. Yeah, it's infinity. So computers can't handle infinity. That's not a number. So what you do is you trick the computer. And here's what you can do. And this will always work. Look at the number of digits we have. Notice there's 3 digits. And here we have 3 digits. Here we have 2 digits. So look at the number of digits. Look at the maximal number of digits. Add 2 more digits and make them 9s. So instead of 3 digits, I'm going to do 5 digits and go 99999. And that will always work. You can do more 9s if you want. But if you add 2 more, it's always going to be good enough to as many decimals you ever care about. Any questions on getting the high? That's the new piece for this one. No, so decimal places don't count. So if these were all, say, 0.4 and 0.6 and 0.5 and 0.2 or something, then 2 more digits would be 99. Do you see how that works? So when I say digits, I mean, the highest number, kind of. Well, really good question. The mean is still 114. The standard deviation is still 23. Yeah, 2 digits more than the greatest number is the idea. P we don't know. So let's plug in 200 and a bunch of 9s. So if I go 200, and I go a bunch of 9s, I need to erase the P equal because I'm going to get a new number, new answer, and hit calculate. Okay, notice you get a really small number, 0.00009233. Okay, so on the picture, it's like way over here. You can't even see it, it's so far away. Do you see? There's like hardly anything to shade in. Okay, by the way, if I added another 9, should that change anything? What do you think? Okay, so you notice in Fortunate you had 9232895. If I hit calculate, get the same thing. Maybe back here, I didn't look at every digit, but as many as you care about. Do you see it, how that works? So 2 digits is going to be enough for your, like, anytime you'd ever worry. Any questions on that example? Okay, let's do the next one. How about the probability that x is less than 90? What's the low? Not 0. It's negative infinity. And we're going to use the same trick is we're going to now do the same thing with 5 nines, but now it's going to be negative 99999. If you plug in 0, you won't get the right answer, by the way. What's the high? What's the high? Yeah, the high is 90. What's the mean is 114. That doesn't change. And the standard deviation is the same standard deviation, 23. So let's go find it. Ah, right here. First thing, this wasn't about students. This was just X. Nothing about students. This could be elevation or something, and you could have negative elevation. Below sea level happens. It could be your bank account, and maybe you owe money. Does that make sense? There's a lot of negative things that could happen. But more important is suppose it follows a normal distribution. As soon as I said it follows a normal distribution, that means we can have negative numbers, even if it doesn't fit for kind of like the rational stuff. And that's what's going on there. Does that make sense? You can't have negative height, and it can't follow a normal distribution, but as soon as you say suppose, you're going to say it can, or it did. It did. You see how that works? That's that word suppose. Because if you cut it off at 0, it no longer follows a normal distribution. If you want to get more fancy, and I'm going to tell you this a lot in this class, any guess on what you're going to have to do? Yeah. In this particular example, you're going to have to change your major into a math major so you know how to do it because it's brutal math. And you're not forced to do that in my class. Got it? Okay, so negative bunch nines, 90. Same mean, same standard deviation, leave the p blank, and we calculate. And you get about 0.1484. Any questions at all? Any questions at all on that example? Doesn't look too hard, does it? Why is everything really complicated math? It just is. Yeah, but again, just trust the calculator and you have to worry about it or become a math major. You choose. Okay. So the next ones, just for time's sake, find the probability that x is greater than 5 given x is less than 125. So then what you have to do is you have to use the given formula. And the given formula says the probability of A given B is the probability of A and B divided by the probability of B. You remember that formula? That happened in chapter 3. So if we are greater than 105 and less than 125, then x is between 105 and 125. Divided by the probability that x is less than 125. So this one actually is going to involve 2 different normal distributions. So our low for the numerator is 105. Our high for the numerator is 125. Our mean, still 114. Our standard deviation is 23. We don't know p, that's left blank. For the denominator, what's the low for the denominator? Yeah, negative infinity. So I'm going to go negative 5/9. And the high will be 125. Mean is still 114. The standard deviation is 23. Any questions on that? So I can go to the calculator. We had 105. Again, it was 105 to 125. Our mean and standard deviation didn't change. I erase the p, hit calculate, and I get this number, 0.33598. I'm going to do the following. I'm going to copy that. And now I'm going to go to my calculator. I'm going to paste it in just so I don't lose it. And then I want to divide by the same thing, but now my low is negative 99999. Everything else is the same. So I go negative 99999. P is now blank. I hit calculate. And now I get 0.6837677. I'll just copy that all in. In the calculator, I'm going to take the first one, I'm going to divide it by the second one. Any questions? And I get about 49% chance. Did I lose anyone on that idea? Piece of cake, right? Not too bad. Okay, so now let's do the IQR. Okay, do you remember what the word IQR meant? What did it stand for? Yeah, that was the interquartile range. And the definition is the interquartile range was Q3 minus Q1. Let me erase that because I haven't done that yet. So I need to find Q3. If I look at Q3 in the picture, what is the low when we're talking about Q3? Do you remember the definition of Q3? The third quartile? What was the definition of the third quartile? The 75th percentile. What does that mean? Any idea? Yeah, 75% of the values are lower than the third quartile. Another way of saying is the probability of being lower than the third quartile is 0.75. So if we're talking about lower than the third quartile, what's the lowest value lower than the third quartile? Yeah, that'd be negative infinity or negative, and then a bunch of nines. What's the highest value? Lower than the third quartile. Yeah, no, the lowest value is about negative 99999. The highest value we don't know. That's the one we leave blank. Remember, we got to leave one blank. 114 is a mean. 23 is the standard deviation. And what's P? What's the probability of being lower than the third quartile? Yeah, 0.75. Any questions? Any questions on how this example happens? Okay, so now my low is still negative 999. My high is what I leave blank. Mean and standard deviation stay the same. P is 0.75. And I hit calculate. And there we go. There's our third quartile. I'm gonna copy that. Let's pop that in the calculator just for now, because we're gonna need it. Well, remember that the interquartile range is the third quartile minus the first quartile. What's the only difference when we're talking about the first quartile compared to what we just did for the third quartile? There's only one difference in terms of low, high, mean, and standard deviation in P. Yeah, the only difference is P now is 0.25. So we still have the low is negative 99999. High is blank. The mean is 114. Standard deviation is 23. And P is 0.25 now. And the nice thing is I can go to the calculator. I just take the 0.75 and make it a 0.25. And remake the high blank. And I hit calculate. There's my high, 98.4867, etc. Now I can subtract that number. And my interquartile range is about 31. Any questions on finding that? Okay. Let's do the next one. The middle 84% of the data is between what two values? Any questions so far? Okay. I put this one on. I didn't used to do this one, but everyone had trouble with this on the homework. So, or the chapter assignment. I figured, I better do one like it. So the idea is that if 84% is in the middle, how much is outside? How much are on the two tails to combine? If 84% is inside, how much is outside? 16%, right? Or 0.16. If 0.16 are the total two outsides, how much is on the left? Yeah, so the left tail will have 8% or 0.08. Okay, any questions on that? Okay, so that, we're going to do something very similar. The low will be negative 99999. The high is what we don't know, because we want to find out the value of x. So we leave that blank. The mean is going to be 114. Standard deviation is 23. And what is the probability is going to be, what's P? What is P? 0.08. Okay, so I go and find it. So my probability now is 0.08. The high is what we don't know. And everything else is the same as before, and we calculate. And there we go. 81.683354 or so is the left-hand side of the middle. Do you see that? To get the right-hand side, well, if the left tail has 8%, the right tail also has 8%. Is that clear? So I can say P is still 0.08, but now the low is what I don't know. And the high is 99999. And I calculate, and 146.316645,887, etc., is going to be the right-hand side of the middle. Any questions at all on how I calculated this middle area? Any questions? All right, you ready for this one and this one I just did because it's easy. Find the z-score for the value of x equals 117. So the hint on this one is we don't need to use a fancy calculator. We just take 117 minus 114 over 23. It's a z-score, right? X minus mu over sigma. 117 minus 114 is 3. 3 over 23 is 0.1304 about. So that one's a quick, easy one. But notice we didn't, you get the z-score and it doesn't look anything like the original x. So if you don't have a standard normal, you're not going to get the same number for z. Any questions at all on that idea? Okay. It's time for one of my favorite normal distribution examples. All right. Suppose, maybe I'll make this bigger so you can see it a little better. Suppose that the time until you or your wife, if you're male, okay, biological male, by the way, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. I just want to let you know a few things. First thing, we write out the distribution x tilde n 140 comma 7. Do you really think the date at which you're going to have a baby is normally distributed? What do you think? Any guesses? It's just a guess. It's biology, not math. Okay. It turns out it used to be, but it's not anymore. Isn't that weird? Anyone know why it's not anymore? So 200 years ago, it was. It's definitely not uniform, by the way. Yeah, it's not uniform. 200 years ago, it was a normal distribution, maybe even 100 years ago. You don't know why? Yeah, C-sections. Yeah. What happens now is if someone's an outlier on the high side, they pull that baby out. Okay. So what happens is you don't have a normal distribution anymore because they've pretty much cut out anything over 2 standard deviations is just C-sectioned out. Okay. Which means that you get that bubble at the end. But in the old days, it used to be normal. Okay. So if you don't believe in going to a doctor, then, getting C-sections, then it will be normal. Okay. By the way, 140 days, what do you call that? If someone asks you something and you say 140 days, what did they ask you? They're not going to say, what is the mean? What is the mean of your having a baby? That's not what, no one's going to ask you that. What are they going to ask you? What's the words that people ask you that's not math words? Yeah. When are you expecting? Yeah, when are you expecting? You've heard that before, probably, right? Okay. So if you're going to say, I'm expecting in 140 days, that's the same thing as saying the mean is 140. I don't know if you ever thought about that, but that's what that means. Okay. It turns out the standard deviation really is 7 days. I looked this up, by the way, not because I'm a doctor or anything like that. But there is an expert on this who I know about as well as anybody I know. Any guess on who that is? I know better than any of you, that's for sure. Better than anyone, than almost anyone. Not just any doctor, my brother. Okay. Turns out my brother. Any guess on why my brother knows more than just about anyone? Okay. Turns out not only is he a doctor, but he actually delivers babies for a living. That's his job. Yeah, he OBGYN, but specialty in delivering babies. So I get a lot of information from him because I can trust the guy. That's what he does for a living. Isn't that cool? Okay, so this is a real example. And so here's a little fun extra to it. Make this a little bigger. Okay, so your boss, okay, has just scheduled you, or it could have been your wife's boss, the whoever's pregnant, okay, for a business trip out of the country, okay? By the way, one of the things you want for your baby is you want your baby to be the president of the United States someday, okay? By the way, do you know who's allowed to be president of the United States and who's not allowed? What's the one major rule about being president of the United States besides getting elected? Yeah, you have to have been born in America. That's in our Constitution, by the way. Okay, so you actually have to be born in America, and in America that could also be Navy base. Yeah. Okay, so you or your wife will leave today and will return in 135 days. Do you think that's okay? Well, let's find out. Okay, let's find the probability that your baby will be born out of the country. Do you see that? It's a long trip, but maybe you're making a lot of money. It's an important job for you. Do you see that? And if you're gonna be able to come back and have your baby in America, then that's fine. Does that make sense? So let's find the probability that your baby's gonna be born out of the country. So guess what? We need low, we need high, we need mean, we need standard deviation. I'll write SD and P. What's the low? And we're assuming it's normal. Yeah, actually, what is the low on this one? Yeah, and this one, the low really is 0 and not negative 99999, even if you assume it's normal. How come for this example? Okay, maybe we can go 99999. It turns out it doesn't matter. You get the same answer. Not negative days because in a way, the baby hasn't been born yet, but we're going to say the low is negative 99999. You can also think of the low being 0 because, you're pregnant. Haven't had the baby yet. Do you see that? You can think of it that way too. It turns out it'll give you the same answer in this case. Okay, the high will be what? What's the high? Yeah, 135. Right? Because if it's born on day 135, then that's the day that you're sitting in the airport or on the plane, so not in the country. Does that make sense? What's the mean? That should be easy. Yeah, 140. What's the standard deviation? 7. P is what we don't know. We want the probability. So now we're going to go back to here. I'm going to hit refresh so I don't have to hit erase on all this stuff. And it just makes everything zeros. I mean, nothings again. And then we could look again. The low was negative 9999. High was 135. The mean was 140 and standard deviation was 7. And we hit calculate. So now we can actually look at this and say, well, are you okay if there's more than a 23% chance of having the baby born outside of the country? Do you think you'd be okay with that especially if you want your baby to be the president someday? What do you think? Would you be comfortable with that? And maybe you're going to a country that doesn't have very good OBGYNs? Yeah, probably not. Probably not. Okay. Yeah, that's a pretty high probability. So one of the things you would say is you don't want to quit your job necessarily. You want to say, well, what would you be okay with? Okay. So you can negotiate with your boss. So here's part B, the next scenario. Okay, you decide it's too risky. And you want to negotiate with the boss to ensure that there is no more than a 1% chance that the baby will be born out of the country. Does that seem more reasonable? If you have a, over 99% chance of having the baby in the US, that sounds a little better, doesn't it? So, what day should you ask to be the return date? Any questions on that? So I'm going to copy and paste these low and high stuff. Okay. So the low will be still negative 9999. What's the high in this case? Yeah, this one's the blank, because that's what we don't know. That's the return date, what we're asked to find. Same mean, same standard deviation, and what's P? 0.01. Good, good. And now we just put it in. So negative 99999, the high we don't know. Same mean, same standard deviation, and the probability is 0.01. Any questions on that? And there's your high, 123.7. So you would say, so in this case, you wouldn't round up because then you have a little bit higher than 1%, tiny bit higher, but still it's higher. You're actually going to be flooring it, so round down to 123. Does that make sense? So we're going to return in 123 days. Any questions on that? Okay, so here's the next question. All right, now just imagine it's 138 days later and the baby still has not been born. Got it? Find the probability the baby will be born within the next 24 hours. Is that clear what the question is? So what we want is the probability that the baby is born between day 138 and day 139, given that the birth is greater than 138. Is that clear? And then we had a formula. And that was a fraction. Do you remember that? So that is going to be the probability of A and B. Oh, let's make this really big. It's too hard to gets really small when you do fractions. There we go. So probability. Now, if it's between 138 and 139 and it's greater than 138, what do you know? Any thoughts? And the idea is this greater than 138 is redundant, because if you're in between 138 and 139, then of course you're greater than 138. So that means the and is just 138 less than x less than 139. And the denominator is the probability that x is greater than 138. Any questions on that? Okay, so now I can go to the calculator, and the low will be 138 for the numerator. The high will be 139. The mean is still 140, standard deviation 7, and the probability, I hit calculate, and I get this 0.0565, etc. I'm going to copy that. Gonna put that in the scientific calculator. And then if you remember, the denominator was greater than 138. What changes here? If I want to be greater than 138, what changes? What changes? What do I need to do? Yeah, I need to make the high 99999. And of course, I want the probability, so that left blank. And it calculate, and that's 0.61245, etc. So I divide. Okay, so there's about a 9% chance that baby will be born in the next 24 hours. Any questions at all on that example? Any questions? Okay. All right, one more example, we'll call it a day. Okay, and this is a kind of a business example. Make this a little bigger. Okay, suppose that the amount of ice cream that you sell each day, so you have an ice cream store. Sound good? Okay, is normally distributed with mean 950 ounces and standard deviation 120 ounces. So we can write x tilde n 950, comma 120. Sound good? Okay, and you get that from researching. You've been in business a while, so you've looked at the data, looks somewhat normal, and there's your mean and standard deviation. Okay, find the probability that on a randomly selected day, you're going to sell between 900 and 1,000 ounces of ice cream. What's the low? Yeah, 900. What's the high? 1,000. The mean is 950, right? Standard deviation is 120. And now I just put in the calculator. So 900 and 1,000. I'm going to refresh so I can get that popped in. 900, 1,000. The mean was 950. Standard deviation was 120. Okay, calculate. There's my probability. About 32% chance. Any questions on that example? Okay. All right. In the morning, you took stock of your supplies. Noticed you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Okay. Why would you care about something like that if you're the owner of this ice cream store? Okay, supply chains. Yeah, the idea is if you run out, that's awful for your business, because then people are going to come to your ice cream store and you're going to say, I'm sorry, we're out of ice cream. And that's like really bad for business, because then they're going to, post on the internet, this place sucks. They didn't have ice cream, even though they're an ice cream store. You see? Yeah, and you're going to lose money in the short term and maybe the long term, actually, because people are going to hate you. So short and long term. So those are the kind of things as a business person you got to think about. So what's the low? What's the low? Yeah, negative 9,999. And if you said 0, that kind of works also. Let's go. In this case, we have 4 digits. Oh, sorry, 3 digits. So we need 5 nines. Okay, it's almost close to 4 digits. What's the high? Yeah, 1100, right? Because that's the most. Oh, I'm sorry. That's what happens when I listen. You're gonna run out. The low is 1100. What's the high? Yeah, that's gonna be a bunch of nines. Because again, if there were people wanted 1 million um ounces of ice cream, you're gonna run out. Does that make sense? The mean is gonna be the same, 950. Standard deviation is the same, 120. Okay, so it was 1100. And then a bunch of nines. And P is what we don't know. We can calculate. So do you think as a manager you'd be okay with that? Yeah, probably not. That's when you go and do what you need to do, which is, hire someone to run down and grab some ice cream supplies so you can have ice cream. Does that make sense? Either you're making it yourself and then you got to start making it right away, or you're buying it and selling it and then you got to buy more and sell it. Okay. Does that make sense? That's how business works. Okay, next one. This is the last question of the day. As I said, today's a little shorter than usual. Okay, let's suppose you want to be 99% certain that you're not going to run out. Okay, how much do you need to have in stock at the beginning of the day? What's the low? Not negative 99999 because if we had negative 99999, we're gonna run out for sure. If you have no ice cream, you're running out. That'd be bad, right? We want to not run out. Wait, let me double check. So in a way, what's the low if you don't want to run out of ice cream? Yeah, that's the one I leave blank. Do you see that? Or actually, sorry about that. The low, if you don't want to run out of ice cream, is what? So the high is what we leave blank, but the low is going to be 0. This is one of those 0 because you can't have less than 0 people come. Yeah, this is one of those where it's actually a 0 because, this is a business thing. Does that make sense? Okay, it turns out it won't matter. And you get the same. You can put 99 negative 99999 just if you want to be more safe. But technically 0 should be fine. The high is what we don't know, right? The mean, that didn't change, 950. Standard deviation also didn't change, 120. What's P? 0.999. And then we plug in. High we didn't know. P was 0.99. And there we go. So we better have, 1,230 if I round up. So, or if you round to the nearest, it's 1,229, which as an ice cream store manager, those are basically the same. Does that make sense? Any questions on how this worked? I will let you know that this is not the main application of the normal distribution. Okay. Remember what this class is really all about. Remember? What is this course all about? What's the name of the course? That's a hint. Yeah, it's statistics, right? And a statistic is a number you get from a sample. Do you remember that? Isn't that what the definition of a statistic was? And it turns out, which we're going to see next week, is that if you look at something about that, then the important thing that we're going to really, really care about is always normally distributed, as long as you have a big enough sample. And that is going to be the big thing next week. Next week is a very deep week, and really, really important. This is like the baseline week. Next week is the whole point of the entire class, kind of. And then we're going to be doing that. So I use the normal distribution for everything, but the reason why comes next week. And then after next week, it's using it. Then we're actually going to do the using. Next week is the reason why. After that, it's doing. Does that make kind of sense? And this week is the normal distribution, so we can see what that is. Okay. The next thing I want to do is give you the secret word. And the secret word for this week, for the webinar, is distribution, because the most important distribution there is in the universe is the normal distribution. Any questions on that? Okay. So again, hopefully you do great on your exams. As usual, I'll be happy to answer questions. I'm going to stop the recording, and if you're watching this on YouTube, then you can always answer your questions using Q&A board or project. So let me stop the recording.